Okay, so we have here is question 8. Two straight roads intersect at point O and cross at angles 6 degrees to one another. On one road, car A is travelling towards O with uniform speed 60 meters per second, and the other road, car B is moving away from O with uniform speed 20 meters per second. Calculate the velocity of A relative to B. Okay, so velocity of A relative to B. So we know that phi B is 20I because it's going across at 20. We're now going to calculate phi A. Phi A is coming down at this angle here and down at this angle here, and it is coming down at 60 degrees and it's coming down at 16. So we have to find out what x and y is, such that cos 60 is equal to x over 16, sine 60 equals y over 16. So x equals 16 cos 60 and y equals 16 sine 60. So we put that into the calculator, and what we can find out from this is it's 8. So phi A is going to be, x is going to be 8, and this is going to be 8 root 3. So phi A therefore equals minus 8I, because it's going to the left, and down minus 8 root 3j. Okay, so what we do next is we rub this out, and we've got what we needed there, and now we have phi A. Now what we have next is we have to figure out what phi AB is, velocity of A relative to B. Phi AB is basically 20I, phi A minus phi B, which is going to be minus 8I minus 8 root 3j minus 20I, and what we're going to get here is minus 28I minus 8 root 3j. Now what we can see from this is that this once again is going in a southwesterly direction. So what we can say here is this is going to be 8 root 3 down and 28 across. Okay, so what we can get from this is we can try and get the angle at which it goes down at. So sorry, I'll actually present it this way. So big. So we can find us this angle here, more appropriate to the length of the sphere, and we have is going this way and down. So what we have here is 28 and 8 root 3. What we do is find this angle x here, such that tan x equals 8 root 3 all over 28. So we got tan inverse x equals tan inverse 8 root 3 all over 28. Put that into the calculator. And what we get there is 26.33. Now, this here is 26.33. Now, we also have to find out what the length is using Pythagoras' theorem. We call this length d. So we can say that d squared equals 28 squared plus 8 root 3 squared. And what we can find out there is 28 squared plus 8 root 3 squared. And then we got to square root our answer. And what we get here is d equals 4 root 61. So we now know that its speed is 4 root 61. Now, once we do that, what we're going to have next is we're going to have to find out what is the distance between A and B. So we want to find out this distance here from A all the way to B. And we're going to use the cosine rules. 450 here, 200 here, 60 degrees here. We want to find out what this distance here is. We'll call this D now, okay? So what we're going to have is A squared equals B squared plus C squared is 2BC cos A. And then we're going to find out that D squared ends up to be 450 squared plus 200 squared minus 2 times 450 times 200 cos 60. And what we find out here, 450 squared plus 200 squared minus 2 times 200 times 450 cos 60. And what we get here, D squared equals 152,500. We're going to square root the answer. And we get 50D equals 50 root 61. So that is simply 50 root 61. So that's what we need from that. Okay. Now, we're just going to consider when we draw this triangle just one thing, alright? So we have O here, okay? And we know that A is located up here. Now, A is located at a distance 450 meters, 60. So we need to find out what X and Y is from A's location to 0. So it's going to be cos 60 equals X over 450. X equals 450 cos 60. So 450 cos 60 is 225. And then finally Y sin 60 equals Y over 450. Y equals 450 sin 60. So we can see is that A is located basically 225 meters to the right and basically 389.71 up high, while B is located 200 meters to the right. So what we have with B is that B is further along. Okay, so we have B is further along. Oh, sorry, B isn't as far along. Excuse me. So if we look at B here, what we can have is B only goes 200 of the way up, so way across, because it's 200 across. So B is here. So B relative to A. So the distance of B relative to A is basically 25 meters across and 389.71 meters upwards. Okay, and as we all know already, that the distance is the same thing as 50 root 61 in the calculator. Okay, so remember B is 25 across, 389.71 up. Okay, so what we have here is we have this 25 over 389.71. Now if I find out the angle X here, I can find out this angle X here, so what I'm going to say is that it's X equals tan inverse 389.71 divided by 25. So tan inverse 389.71 divided by 25. We get is X equals 86.32. So basically what we now know is that it's 89 if you put this line here, it's 86.32 upwards here. This is 86.32. Okay, and it's 50 root 61 up. Now, what we're next going to do is we're next going to input the velocity of A relative to B. Okay, so the velocity of A relative to B. So, velocity of A relative to B, as we all know, is minus 28 over A root 3. So, what we're looking at here is recreating this direction here onto our graph. So we're going to recreate this direction here onto our graph, about this far. Okay, and what we can then see is we're then looking to find out at what point is at its closest distance. It's at its closest distance when it hits around 90 degrees, around there. So we have to find out what is this point X, how long does it take to go from here to here. Now to do this, we're going to have to zoom in on some angles. Okay? So, what we know already about this triangle is that this here, oh, and by the way, that's 86.33 when I round it off properly. 86.33, 86.33. Okay, so we know that this angle here is 26.33. We use alternate angles, and what we also know is that this angle here, going from here all the way to here, is 86.33. This means this is an angle of 60 degrees in here. So this is an angle of 60 degrees. So what we're going to get next then is that's going to be 60 degrees. A travels along to the point X at which they're closest to B. That's going to be 90 degrees. This is the velocity of A relative. This is the path VAB. All this path here. And then basically we know that this already is 50 root 61. So I have to find out what this length AX is, or we'll call it, once again, call it distance D. Alright, so what we're going to get is cos 60 ends up to be D over 50 root 61. D over 50 root 61. So D is equal to 50 root 61 cos 60. And 50 root 61 cos 60 put into the calculator. What we get is 195.256, or what we get is 25 root 61, or 195.256. Now remember, we have to figure out how much time it takes to go from here to here. So remember, our speed along this line is 4 root 61. So what we're going to do next is we're going to divide distance over time. So, distance over speed. Time equals distance divided by speed, which ends up to be 25 root 61 divided by 4 root 61. And what we get here is 6.25. Okay, 6.25. Now, the next one is find when they're equidistant from O. That's part 2. Now, oddly enough, part 2 has absolutely nothing to do with part 1. So we can basically get rid of all our workings from part 1. Okay, and just concentrate solely on part 2. So, what we get this time around is it's equidistant from O. So what you got to remember is B is going away from O. So if you zone in on this, you can see that B is traveling 20 meters away from O. So B starts off, the distance of B from the origin, it starts off at 200 meters. and every second it travels 20, so 20 multiplied by t. 20 meters for every second it travels. dA is different, it's 450, and it's getting 16 closer every time, so it's minus 16t. So basically 200 plus 20t will equal 450 minus 16t, and what we're going to get when we cross multiply this is going to be 36t equals 450 minus 200. 36t ends up to be 250 meters, so 250 divided by 36, and we get t equals 6.94.